This is on acids and bases. We're going to talk about the different properties, their different definitions for an acid and a base, so how can you tell them apart, neutralization reactions, and if you have a weak or a strong acid or a base. And then we're going to end it with titration. So first let's talk about the properties of an acid. So both of them contain electrolytes, which electrolytes are just when you add them to water, they break down into their ions. So both of them do that. And because they both produce electrolytes, they're both good conductors as well. Acids have sour taste. They turn litmus paper red. They stay clear in phenolphthalein, which phenolphthalein is just an indicator. So if you see this says clear and basis says pink. Acids react with metals to form hydrogen gas, and some examples are vinegar, milk, soda, apples, and citrus fruits. And if you can tell, these substances, these examples, they have a lot of these properties. The properties of bases are complete opposites, so if you can remember acids, you should be able to remember the bases. Now, bases also perform or produce electrolytes as well, so when you dissolve them in water, they're going to form ions. They have a bitter taste, turn litmus paper blue, turns pink when you add phenolphthalein to it, slippery feel when it's wet. Some examples: ammonia, lye, antacid, and baking soda. Now for the definitions. There are two definitions for acids and bases. You've got to know both of the different definitions. So the first one is Arrhenius. Arrhenius said that an acid will form hydrogen ions when put into water. So for example, HCl, when you put it into water, it's going to break down into H plus and Cl negative. So therefore this is an acid. He also said pretty much with this definition, if there's a hydrogen in it, meaning just H, then it's going to be an acid. If you compare this to a base, it's going to form hydroxide ions. So in order to form a hydroxide ion, it has to have OH in the chemical formula. So here we go. So acids have an H in front. Bases are going to have that OH in the back. So when you put it into water, it's going to dissolve into the Na plus and OH negative. The problem came when they discovered NH3, which is ammonia. This is basic because it follows all the properties of a base, but there's no OH there. So therefore, they had to come up with a new definition. It can't just be the hydroxide that makes it a base. So Bronsted-Lowry changed it to this. He said that acids are proton donors. If something is a donor, this means it gives it up. So your acids are going to give away H pluses. Your bases are going to take them in. They're going to take them. So in this example, NH3 is what you start off with. When you have the reaction that occurs, it becomes NH4. So you simply look at the hydrogens and see whether it lost or gained. So in this case, it went from 3 to 4, so it took a hydrogen, so therefore it's a base because it took in the hydrogen. Next is pH. You should have talked about this in biology, so we're going to take it to the next level here though. It's not just about reading the scale. You have to actually calculate pH and pOH and all that stuff. But for right now, you just need to know that pH is the negative logarithm of the concentration of your H plus ions. And that's shown simply by the formula that you use to solve for pH. So this is the negative log of the concentration of H plus. So the pH scale, if you can remember, is from 0 to 14. The lower it is, it's more acidic. The higher it is, the more basic it is. 7 is neutral. Okay, and that's explaining that right here. Now, everything produces an H plus concentration, so it's about how much they produce that makes it an acid or a base. So not only do you have to be able to tell an acid from a base, you also have to be able to tell strong acids and bases from weak acids and bases. So it all comes from this word dissociate, which means to break down into its ions. So strong acids and bases completely break down into ions, whereas the weak ones only partially do that. So strong acids and bases are better conductors because they dissociate completely. So they're able to produce electricity stronger than your weak ones are. When you have an acid and a base reacting together, this is called a neutralization reaction, and you're always going to get a salt and water. So this is shown here. So if you have an acid and a base reacting, so these are your reactants, it will always produce some sort of salt and water. Now by the word salt, this means ionic. So you're going to form some sort of ionic compound in H2O. So for example, HCl, when it reacts with NaOH, you're going to form NaCl plus water. Another example, this is simply vinegar plus sodium hydroxide will produce sodium acetate and water. Neutralization does not mean the pH is equal to 7. Titration is an analytical method in which standard solution is used to determine the concentration of an unknown solution. You do this by adding a solution that you know the concentration to and look at the unknown solution by finding the equivalence point. The equivalence point is when you have equal amounts of H plus and OH negative, and you're able to tell when you have equal amounts if there's some sort of dramatic color change, so you have some sort of indicator in the solution. Or you can tell a dramatic change in pH by some sort of graph and you're calculating the pH.